Good afternoon, my name is Jake Mocholtz. I'm the CEO from IneEight, and today we're going to be providing on a webcast what advanced work packaging can do to help your business, whether you're an owner, an engineer, or a contractor. So first, what I'd like to do is introduce the company. IneEight is really charged with delivering predictable project outcomes. We've been in business for 30 years. We've been very fortunate to have over 300,000 users using our solution. We cover 8 product categories, which I'm going to talk about here in a second. And our headquarters is based here in Scottsdale, Arizona. Now let me describe a few of our customers, or our key customers. We have customers from owners, contractors, to engineers. And it really takes all of these different customers coming together in order to capitalize on the advanced work packaging philosophy. We have customers as large as ExxonMobil, all the way down to small contractors and subcontractors utilizing our software to improve their productivity. So next, let me describe the IneEight solution portfolio. We cover all of the end-to-end solutions in 8 product categories. We start with project cost management with the estimating, budgeting, and forecasting. Then we cover connected analytics to reporting and dashboarding, all the way to safety, quality, and compliance. And it really takes all those solutions put together through the digital thread in order to create a great AWP practice that I'm going to describe in a second. So what is advanced work packaging? It's all about getting the right people, the right stuff at the right time. And it takes engineering, procurement, and construction coming together, working together, whether it's the owner, the contractor, or the engineer, and really starting with the end in mind, starting with construction and developing that path of construction in order to create a great AWP practice. So next, I'd like to provide you with the top 3 reasons we believe it's important to adopt an advanced work packaging philosophy. Number 1, it reduces schedule and costs. CII has published that the total cost of installed work can be reduced by up to 10%. Number 2, it increases your productivity in your field by ensuring that people have the right material, the right equipment, work instructions. The time on tools can be increased by up to 25% out in the field. And number 3, it improves predictability. By establishing stakeholder collaboration early in the process, the project can be designed constraint-free and be able to execute in the field. So now let's take a look at the tools that are needed in order to achieve an AWP process. Both IneEight, CII, AACE all believe these are the tools that it takes. It starts on the left with the design tools, tools such as Autodesk, Bentley, Intergraph. These are all the tools that the engineering model will be developed on. Then from there, that information is attached to a virtual design and construction model. This is really that model that the construction team is going to be able to lever in order to provide visual context of the project. To that, we also have fabrication tools that are needed during the process. This is where you'll get your structural detailing, steel fabrication, pipe fabrication, and alike. We bring all that information into a virtual design and construction model. We tie that off with work packages, documents, estimates, and cost controls are then also attached to this particular work packaging. The master schedule information is attached, quality and completions, procurement and site materials, and ultimately progress tracking is all the tools that we need, and it's all held together through digital threads. And then on the bottom, we get all the reports and dashboards that you need in order to really effectively manage this AWP process. So let me give you a little bit of an overview of what AWP means to IneEight. It really starts with the schedule, works its way into the execution tools, balances out with the model, then ultimately the information falls out into reports and dashboards that can be levered by the project and then into completions. And so now we're going to dive into a little bit more detail into what those tools are that make up the AWP practice. We are now going to transition from the IneEight AWP overview into the details of how the data flows seamlessly through the entire lifecycle of the project. In our opinion, this is where the real value of the AWP process is achieved. We no longer have to work in data silos in order to achieve the best path of construction. For example, our estimates can remain in sync with our schedule and our model as real-time changes occur through the pre-planning phase. Before we review the data flow for the 4 phases of the project, from pre-planning to turnover, it's important to level set on some common AWP terminology. We begin with the project setup. During this phase, we will align the stakeholders, including designers, construction, commissioning, and owners. This step is key to the overall success of the project. Next, we will identify the best path of construction, which is defined as construction work areas, or CWAs. To achieve the best path of construction, resources are optimized during the pre-planning phase. Next, engineering, construction, and procurement work packages, EWPs, CWPs, and PWPs are developed to facilitate unconstrained completion of construction work areas. This phase facilitates the identification of engineering data, drawings, long lead procured items that allows the construction teams to build a scope of work without obstacles. Next, work phase planners will break down construction work packages into manageable pieces of work that allow individual trades to operate independently in 1 to 3 week durations called installation work packages. So now that the construction work packages have been broken down into manageable pieces, construction work can begin without constraints. To make the IneEight data flow more vivid, we'll use a construction project of adding 2 additional drills and a processing facility to an offshore oil platform. You can see how the construction work packages are laid out by discipline. Our example will focus on the data flow for the concrete and piping of the onshore facility. So now we will begin with the pre-planning phase of the project. Typically, this phase has very little data collaboration between scheduling, estimating, and engineering. The IneEight data flow allows for the constraint-free collaboration between these departments. The pre-planning process begins with pulling in schedules from historical performances on previous project. The project can be files from other enterprise softwares such as Oracle Primavera or Microsoft Project. Then the IneEight AI engine will make suggestions on sequence, durations, and quantities from previously completed construction work areas and packages. Sequencing for this project can then be synced to the estimate to update quantities, work hours, costs, and revenue. Next, stakeholders will become involved in the schedule logic through the IneEight workflow engine to ensure construction work area logic, durations, risks, and constraints have been properly captured. Risks that have been identified are passed to the IneEight estimate to be further priced. Finally, a Monte Carlo simulation is run to determine the most likely outcomes for cost and schedule in the IneEight schedule solution. The result is returned in terms of probability for the project outcome. The final step in the pre-planning phase is to update the quantities either using a 2D or 3D takeoff. If the model is available, the estimating structure is passed to the IneEight model, then the components of the model are related to the structure through a set of rules called data transformation operations. As the new revisions of the model are complete, the quantities from the estimate can be updated in real time. Finally, the estimate can be compared to historical performance by using the benchmarking feature. Now that we have completed a realistic estimate and schedule backed by engineering, risk, constraints, and benchmarks in the pre-planning phase, we can utilize this information to begin the planning phase. We begin the planning phase by updating the CPM schedule with additional information about construction, engineering, and procurement work packages. Then we begin to build the structure for the installation work packages. For this example, we will focus on the installation work package for the concrete footings. This structure is then passed to an IneEight plan and model so that the work hours, quantities to be installed, and crews can be assigned to the work can be populated. The next step in the process is to populate the installation work packages with items of work that need to be accomplished in a 3-week time frame by crew or by discipline. In this example, we have grouped together an isometric of piping that will populate this particular IWP. IneEight plan will associate the work hours needed to complete this task, and IneEight model will link the documents together that are needed to complete the IWP. Next, the workphase planner will provide work steps such as safety, quality, and compliance checklists that are needed to be associated with this IWP. Inside of IneEight Plan, items of work that are not captured in the model, such as rebar installation, can be built into the IWPs as well. The dashboards will be used by the entire project team to ensure planning activities stay on track and constraints are removed before IWPs are issued to the field. IneEight utilizes Microsoft Power BI to display this information together, along with many other useful dashboards in one place, serving as a single version of the truth for the project. To complete the planning phase, installation work package information is passed back to the IneEight schedule. Next, short interval planning can be accomplished by field personnel. This process is used by superintendents and foremen to move cards around based on crew availability and many other factors such as weather. This view also provides context from the CPM schedule to support a 3-week or 90-day scheduling activities. Short interval planning allows the CPM schedule to stay in sync with the actual work activities in the field. Now we are ready for field execution. Because all of the information has been linked up to this point, we're simply looking to capture field progress and allow this information to update all of the systems. Moving into the field, IneEight Progress application allows foremen and superintendents to review instructions, drawings, model shots, inspections, material required, and many other necessary items. Then they can capture progress on an offline mobile device. This information then updates the schedule and allows for progress to be seen visually on the model or in the dashboards. The next slide shows how data can be consumed at a project or portfolio level. Individual projects can be turned on and off to highlight areas of the portfolio that need to be reviewed by management. These dashboards can be shared by the owner, contractor, and engineer to keep the project on track for both cost and budget. Finally, all of this information can be turned over to the owner at the end of the project and can be used as a digital twin of the assets. This is an example of how data that has been captured from an airport terminal project and shows how the documents can be retrieved from the model along with pictures and other useful information for operations and maintenance. Again, we believe that a great AWP practice utilizes the data starting from the pre-planning phase and ending in the turnover of the project. This information serves as a digital thread throughout and supports achieving superior project outcomes. So why is IneEight the best choice for the AWP process? Number one, we provide knowledge-driven forecasting. We leverage historical data in order to provide data to start the project that you're working on. Number two, we have a truly integrated field execution solution. By capturing data out in the field, we can update the rest of the processes and the rest of the systems that we utilize. Number three, digital thread enablement. So we start with the design and we end up with a closed out project. And the data that starts at the design works its way through all of the solutions in order to end that project. Number four, we provide visualization to the project throughout the life cycle. So whether you like looking at reports, dashboards, or maybe looking at the model in order to describe the progress and any potential issues that are on the project, we cover all three of those facets. Number five, we provide deliverable-based planning. Starting with the construction in mind, we eliminate all the constraints that can happen throughout the life cycle so that we can have a flawless field execution. And number six, we provide collaboration and coordination. Provides flexible workflows throughout the solution so that everybody can participate. In closing, hopefully you've gained some insight on how to achieve the best path of construction using AWP. And if you're interested in learning more about AWP, I encourage you to watch our unique upcoming Best Path of Construction webcast series, which sets out to highlight and discuss various dimensions of advanced work packaging, from building realistic plans with a knowledge-driven approach to modeling success through coordination and digital threads. Each webcast will provide you with a unique perspective and voice that will be hosted by our industry experts, Dr. Dan Patterson, Max Risenhoover, Brad Barth, and many others. Visit IneEight.com/AWP to see the latest, or give us a call today at 866-308-7853 to get started today.